The history of the Earth describes the most important events and fundamental stages in the development of the planet Earth from its formation to the present day. The age of the Earth is about 4.56 billion years. Nearly all branches of science have helped us understand the main events of Earth's past. The Earth is about one third the age of the universe. Earth and the other planets formed about 4.6 billion years ago. They were made of the leftover gas from the nebula that made the Sun. The Moon may have been formed after a collision between the early Earth and a smaller planet, sometimes called Theia. Scientists believe that parts of both planets broke off, becoming the Moon. Earth's water came from different places. Condensing water vapor and comets and asteroids hitting Earth made the oceans. Within a billion years, the first life evolved in the Archean era. Some bacteria developed photosynthesis, which lets planet make food from the sunlight and water. This released a lot of oxygen, which was first taken up by iron in solution. Eventually, free oxygen got into the atmosphere or air, making Earth's surface suitable for aerobic life. This oxygen also formed the ozone layer, which protects the Earth from the bad UV radiation from the sun. Complex life on the surface of the land did not exist before the ozone layer. Proterozoic life. The first advanced single celled and multicellular life roughly coincide with the oxygen accumulation. This may have been due to an increase in the oxidized nitrates that eukaryotes used as opposed to cyanobacteria. It was also during the Proterozoic that the first symbiotic relationship between mitochondria and chloroplasts and their host evolved. Eukaryotes such as Acritax blossomed as this cyanobacteria in fact. Stromatolites reached their greatest abundance and diversity during the Proterozoic, peaking roughly 1.2 billion years ago. Classically, the boundary between the Proterozoic and the Paleozoic was set at the base of the Cambrian period when the first fossils of animals known as trilobites appeared. In the second half of the 20th century, a number of fossil forms have been found in the Proterozoic rocks, but the boundary of the Proterozoic has remained fixed at the base of Cambrian. The build-up of oxygen. One of the most important events of the Proterozoic was the accumulation of oxygen in the Earth's atmosphere. Though oxygen was undoubtedly released by photosynthesis well back in the Archean times, it could not build up to any significant degree until chemical synths. Unoxidized sulfur and iron had been filled until roughly 2.3 billion years ago. Oxygen was only 1 to 2% of its current level. Banded iron formation, which provides most of the world's iron ore, were also a prominent chemical sink. Most accumulation ceased after 1.9 billion years ago, either due to an increase in oxygen or a more through mixing of the oceanic water column. Red beds, which are colored by hematite, indicates an increase in atmospheric oxygen after 2 billion years ago. They are not found in older rocks. The oxygen buildup was due to two factors: a filling of the chemical sinks and an increase in carbon which stored organic compounds which would have been otherwise been oxidized by the atmosphere. At the beginning of the Archean, the Earth's heat flow was nearly three times higher than it is today, and was it still twice the current level by the beginning of the Proterozoic. Thus, tectonic and volcanic activity were more active than they are today. The Earth's crust was not only thinner than is today, but broken up into many more tectonic plates with numerous hot spots, rift valleys, and transform faults. The existence of plate tectonics in this eon is disputed. It is an active area of modern research. Archean geology. The oldest rock formation exposed on the surface of the earth are Archean or slightly older. Archean rocks are known from Greenland, the Canadian Shield, Western Australia, and the Southern Africa. Although the first continents formed during this eon, rock this age makes up only 7% of the world's current cratons, even allowing for erosion and destruction of the past formations. Evidence suggests that only 5 to 40% of the present continental crust formed during the Archean. Small fragments from the space collided to become large fragments, including one collection about 150 million kilometers from the center. This would become the Earth.